السلام عليكم ورحمة الله وبركاته. So from today onwards, inshallah ta'ala, we are going to be beginning our computer science course for A2, right? So the very first chapter is data representation. And in data representation, the very first thing we learn about are floating point representation, right? And we're going to talk about it in a second. So the chapter name is data representation, data representation. Okay, data representation. And in that, the very first thing we're learning here is, you know what? Let's just do this. So that is the very first chapter for computer science, CS 9618. And I don't really think there's a need to mention all of that because, I mean, obviously, if you clicked on this video, then you must have already seen all of these things, right? Now, let us talk about this, like what even is this. So in AS levels and also in A levels computer science, and honestly, let me tell you one thing before I start about my lectures. I do talk a lot, okay? So you do have to listen to me carefully. I will do my best to speak slowly in a way that is lucid and a way that is easier for you to understand. I'm going to keep my pace slow as I speak and as I write, you know, so that everyone can walk alongside us, right? Nobody's no student, no pupil is going to lag behind. Now, in O levels, let's start, okay? Bismillah. In O levels and AS levels computer science, we have already learned about representation, right? So if I write a decimal, we know that there are different number systems. There's the hexadecimal number systems, there's this, there's that. However, let me give you an example. If you have, let's say, 128, right? Or let's say you have 6, right? Then how would you represent it in the binary number system? So in the computer science curriculum or syllabus for Cambridge, this is what we do. We try to convert the same number or the same quantity across different number systems. We do that, right? So if this is in the decimal form, or you know what, rather I should write binary form or denary, however you want to pronounce it, in the binary form, then in the binary form, this is how you write it. How would you? This is how you would. A 1, 2, 4, 8, right? So that would be 0, 1, 1, 4, 5, 6. Yep. This would be the binary form for that, right? I'm not going to explain how I did it because I mean you should know that from A levels and AS levels and O levels, right? What are we going to be learning in in today's lecture, right? And what do I mean by case one? How come that makes any sense? That is one thing. So floating point representation, we already know, let's say if somebody gives you 52 and asks you convert that into binary, right? Or if somebody gives you the binary and then they ask you to write it into binary, right? How would you know that already? However, have you ever thought if you were given 52.6, how will you convert that into binary, right? How do you even represent that? I'm not even trying to say, what would be the binary representation for that. Like, how would you represent it at all, right? This is what we are going to be learning today. So, floating point actually means, you know what? Decimal numbers in computer science terminology, decimal numbers which have a point in them, yep, decimal numbers are called real, right? And at the same time, if any of you have ever, learned Python, or even if you haven't, it's good to know that they're also called float, right? So one is an integer, right? But 1.0 would be a float, you know, or a real number, or a real number. I mean, that's just basic, simple maths. Real number. This was the terminology, okay? Now, let's get on to how do you represent that? Because look, I don't really think, like, just think to yourself. In computer science, you're not always dealing with integers, are you? Most of the time, you're dealing with float numbers, right? You know, the clock cycle happening inside your core to do or inside your processor, all of that is dealing, it's not dealing with discrete values, it's dealing with real numbers, right? So how do you represent that? Okay, let's go for the representation. And this is where the actual thing about today's lecture begins, right? Representation. So every time you have been given in as a binary value, a number, let's say 192.5, you, instead of looking at this number as a whole, like this is one big thing, it's better to do it this way. This thing has got two parts. There's the integer part, which is 192, right? And then there's what? There's the decimal part. Now, dividing this matters a lot. Why? Because this division allows you to represent it, right? So this is what we actually do. We represent, or we find the binary for the integer, right? And then we find the decimal part, right? And then we try to convert that into binary. So we have ourselves two binary values, right? Now, how would you do that? Let me show you in just a sec. So this is case one. This is what we are going to be learning today. Case one here is the following. You have been given a floating point number, or a decimal number, right? A decimal number, and you have been asked to convert it into a binary number, right? There are in total four cases, right? And you better do these, because if you are not doing this, if you're not prepared for this and you walk into the exam, believe me, you're just going to be losing free marks, right? Because this is something which appears in almost each and every single one of the exams, right? Every single yearly, you're going to put your hand onto it. You lay your hands on, you're going to see a question. Like one case out of the four is going to be there for sure. You are surely going to see that. Okay. So how do you do it? Let's go for 192.5. Let's say the exam question says 192.5, convert that into binary. How would you? So the very first step is to ignore the point part. Let's just ignore it. Let's just pretend it doesn't exist, right? It's having an existential crisis. I know my jokes aren't good, so never mind. But 192, okay? Now let's just focus on 192. If you were just given 192, how would you have been solving it? My question to you is this. You would write 192, all the powers of 2 from 0 to 7, right? 192, 128, and then it was 64, 32, and then it was 16, 8, 4, 2, 1, right? Now, how many of these would I have to add in order to get myself a 192? Well, obviously, this goes here, right? I mean, 192 needs to be there. How much is 192, 180, how much is 120, how much is 128 plus 64? That would be 12, 6, 7, 8, 9, 1. You see? And then the rest of them are zeros. That's our answer, right? So this gives us 192 in binary. Now let me tell you one thing. You know what? Let me explain to you one thing. Just like on the integer side, since we were kids, since the days of O levels and A levels, the integer side is written as this, 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. On the decimal side, on the point side, right, it's written this way. 0 raised to the power negative 1. 0, sorry. 2 raised to the power, sorry, not 0, 2 raised to the power negative 1, 2 raised to the power negative 2, 2 raised to the power negative 3, 2 raised to the power negative 4. This is how it has been done, right? Or in other words, you can also write it this way: 1 over 2, 1 over 4, 1 over, 8, sorry, 1 over 6, 1 over 8. It's just this, So if this is 1, 2, 4, 1, 2, 4, 8, right? I'm sorry, there was no 6. That was a grave mistake. This is how you do it. So it's exactly like you have been doing. The only difference is that, you do this integer part the same way you have been doing in AS levels and O levels, right? The only new thing in the first step is that you also write the integer part for that as well, right? I'm not going to remove this. I'm just going to, put it at a side. Okay. This is how you write it. Now, over here, I would recommend you to memorize these values, okay? Because it's better to memorize them. That's how I did it in my exams, right? So the values are 0, just like you have memorized these values 1, 2, 4, 8, right? You should memorize these values as well. The first value is 0.5 because that was because that was a 1 over 2, right? And then the next value is 0.25, right? Then you have, you know what? I'm forgetting. Let me, you know, do it for myself. 1 over 8 would be, yes, it was 0.125. Then there's 0.0625, right? And the last one here is 0.03125, okay? Out of all of the past papers that I, prepared my students for, there was no question which required a value greater than that. But if you need it, then it's equal to 1 over, 32. Even though you're not going to need it, believe me, you're not going to need it. But even if you do, let's say, I'm sorry, that wasn't equal to 1 over 32, that was equal to 64. Because this is equal to 1 over 32, okay? So 1 over 64 would be 0.015625. You're not going to need it till here, but it's good to know it, right? But what you must know are these values, right? These are the values you must know. So the very first thing that you have to do the moment you have been given a decimal number and you have been asked to convert it into a binary number is this. You do the integer part exactly as you have always done it. Just write a dot and now try to, you know, um, do the same thing with the decimal part, right? Now, how do you get a 5 here? Sorry, I mean, how do you get a 0.5? I'm sorry, I just circled the 5. I should have circled zero point 0.5. How do you get a 0.5 in here? What numbers out of these do you have to, I mean, all of them, do you have to add up to get a 0.5? Obviously, just the 0.5 because this is the smallest value, right? And yep, the dot is going to be here. The decimal point is going to be here. The rest of them are obviously going to be 0. This was our first step. That was step number 1. So we are done with the first step. Now, what we have to do here is this. I'm going to copy this entire thing. Copy it. You know what? I'm going to place it here. Now, the second step for this is going to be the following. The second step is you pick this thing up, this dot, you have to pick this thing up and you have to take it all the way to the end, right? You have to take it all the way to the end. Sorry. So it would be 1, 2, 3, 4, 5, 6, 7, 8. This is not where it's supposed to be. You need to write an extra zero and then this. Wait, I'm sorry. It needs to be here. It needs to be here. So because how do you know where do you have to stop, like over here or like where? The only way you're going to know it is you have to stop it exactly where the last one appears. The last one appears, right? So this is where the last one appears. I mean, you shouldn't have stopped it over here. Why? Because this is not the last one. This is the last one. So you have to, stop your arrow exactly after the last one. Okay. So, and you have to keep on counting these as well. 1, 2, 3, 4, 5, 6, 7, 8, right? And because there wasn't anything on the left side, we placed a 0. Now, how many of these even are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. Now, how many of them are there? 8, right? You need to find the binary for 8. Now, it's 8, 4, 2, 1, 0, 0, 0, 1. The binary for 8 is 1, 0, 0, 0. This is going to be your exponent. This is what we call the exponent, right? And this entire thing is going to be your mantissa. Mantissa. This is how you're going to write it. I'm sorry. And that would be 0, 1, 1, 0, 0, 0, 0, 0, 0, 1. Right? Look, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep. And we have got ourselves the mantissa. So, there, I hope it all makes sense. Let me check how much time has it been since I began recording, because I need to, consider the total time I spent recording each video, right? It's been 17 minutes. Not way too much, okay? So now look, a couple of more things you need to know before you go. So in binary, uh, floating numbers or real numbers or numbers with decimal points in them are represented in binary not as one binary value but two binary values, right? One of them is what we call the exponent, and the actual integer value is what we call the mantissa. This is called the mantissa, okay? And remember one thing, you write the exponent the way you have written it over. You know what? I'm going to tell you that later. But let's say in the exam you were given, look over here, it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 bits, right? Let's say you were given 12 bits. In the exam, this is how they do it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So in total, there are 12 bits in here, right? How would you write it? In the exam, if you have been given this, always write the mantissa starting from the left side. I mean, you don't write it this way. You don't start writing it this way, like, 1 here, 0 here. You're just going to mess it up for yourself, okay? This is how you write it. You start writing it from the left side to the right? So it needs to be 0, 1, 1, 0, 0, 0, 0, 0, 0. There were 6 of them, and then 1. And then the remaining ones needs to go here. You're just going to, if a bit is remaining, you just write a 0, right? Okay, so always write the mantissa from the left to the right. Okay, and this rule is opposite for writing the exponent. Why? Because they're going to give you two separate, bits, right? Two separate spaces for writing the mantissa and the exponent. Let's say for now that you have calculated your exponent, let's say the space that they have given you is 6 bits. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, 7. Let's say they have given you 7 bits. And they've said, write your mantissa over here. You already wrote it left to right, right? Now, what about the exponent? We know our exponent is 1, 0, 0, 0. So you don't write it the way you write the mantissa. For the mantissa, you write it, if this was the mantissa, I would have written it this way, 1, 0, 0, 0, right? But with the exponent, You write it from right to left. Okay, so this is how we're going to write it: 0 0 0 1, and then the rest of the bits you just write a 0 in here. This is the exponent, right? Now if you still don't understand, let me show you what would have been wrong, right? If I was to write it, never mind. 1 2 3 4 5 6 7. If I was to write it this way, 1 0 0 0 and then 0 0 0, that would have been gravely wrong. You're going to lose marks on that. So always remember to write the mantissa from left to right and the exponent from right to left, right? That is one important thing you should have. Left, dude, come on. Left. Okay? So this is how you're going to write it. 1 1 2 3 4 5 6, right? So 0 0 0 1, and the rest of the remaining bits you just write a 0 over there. Okay, this is how it's done. It's just simple as that. So this was our first case, and I did say this was the first step. If you do want to divide it into steps, let's do it. So the very first thing we did was separate these two, right? And then this is what we did. We wrote all of the powers of 2, right? Then we put a dot after that, and then we began writing the the point side of the powers of 2, and that is 0 0.5, 0 0.25, and so on, and you've got to memorize these values. This was the first step, right? Then moving the point is the second step. You know what? I do apologize for my writing. Moving the point to the last one, right? Moving the point to the last one. Once you're done with that, you just write your mantissa and your exponent into the right places. That would be step number 3, right? So just do remember. And you know what? Once you know all of the 4 cases, it's going to be confusing. Let me tell you that in advance, right? You cannot expect yourself to just know it right away. When you open the yearlies or the topicals, right? You're going to be confused. You're going to look at the question and you're going to think like you just didn't study anything, even though you just got all the concepts. So it doesn't mean you're dumb. It might mean you're stupid though. Just kidding, never mind. So just try to do it. If you don't understand it, come back to the notes, take a look, and it's all going to fall into place. It's just going to happen slow and steady, right? So we know the first step, converting a positive positive decimal number from denary to binary. Now we know that. So the second case is going to be, and that is going to be in the next lecture, okay? Case 2 would be negative 192.5, negative 192.5, right, to binary. Where is it? Yep, positive 1. Okay, this is what we are going to be doing the second lecture. This is how there are 4 cases. The first case is a positive decimal number to binary. The second case is a negative decimal number to binary. The third case is going to be, a positive binary number to binary, and then the fourth case is going to be a negative binary number to binary. Might sound a bit intimidating, but it's going to be okay. Inshallah, I'm going to meet you in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh.